There are several key reasons why running exposed cable up a pole, particularly to a height of 20 feet, is not advisable and often prohibited by electrical codes. Firstly, safety is paramount. Exposed cable, especially at a height where it might be accessible or could potentially fall, presents a significant tripping hazard. Someone could inadvertently come into contact with the cable, potentially leading to a fall or, more seriously, electrical shock if the cable is damaged or improperly insulated. If the cable were to come into contact with other power lines or metallic objects, it could create a dangerous short circuit, posing a fire risk. Secondly, the impact of weather elements is a crucial consideration. Exposed cable is directly subjected to the rigors of wind, rain, snow, and ice. Prolonged exposure to these elements can degrade the cable's insulation, leading to electrical shorts, ground faults, and ultimately, potential fires. The constant flexing and movement caused by wind can also weaken the cable's conductors and connections over time. Thirdly, aesthetic considerations, although not directly related to safety or functionality, are relevant. Exposed cables running up a pole can be unsightly and detract from the overall appearance of a property. This can be a concern in residential areas or commercial spaces where maintaining a neat and organized appearance is desired. Beyond these general concerns, there are specific electrical codes and regulations that explicitly prohibit or restrict the running of exposed cable on poles. These codes are established to protect people and property from electrical hazards. The specific requirements can vary depending on the jurisdiction and the application, but they generally prioritize safety and proper installation practices. For example, the National Electrical Code, or NEC, outlines specific guidelines for cable installations. It emphasizes the need for proper protection against physical damage, environmental factors, and potential electrical hazards. Article 300.3 discusses the integrity of the components. Article 310 addresses conductors for general wiring. For instance, NEC Section 310.15 outlines ampacity tables for conductors based on insulation type and installation conditions, ensuring that conductors are not overloaded, which can lead to overheating and fire. NEC Section 310.16 provides ampacity ratings for conductors. Section 310.17 and beyond details adjustment factors for ambient temperature and the number of conductors in a raceway. Article 392 pertains to cable trays. Cables installed in cable trays must be securely fastened and supported. NEC Section 392.3 outlines the installation requirements for cable trays. Article 396 covers messenger-supported wiring, which is often used for outdoor cable runs. It includes specific requirements for the messenger cable, the method of support, and the types of cables that can be used. For all these reasons, when running cable that will be exposed to the elements or in locations where physical damage is possible, it is essential to use appropriate installation methods such as burying the cable underground or running it in a protective conduit. Conduit provides a physical barrier against weather, impact, and other potential hazards. Underground installation offers a more discreet and protected solution, minimizing the risk of damage and ensuring a safer and more reliable electrical system. When installing cable underground, it is crucial to follow NEC guidelines for burial depth and proper backfilling to prevent damage from soil conditions or digging activities. In summary, the combination of safety concerns, weather-related risks, aesthetic considerations, and adherence to electrical codes makes running exposed cable on a pole an inappropriate and potentially hazardous practice. Proper installation methods, such as using conduit or burying the cable, should always be employed to ensure a safe and reliable electrical system. Firstly, consider the potential for physical damage. An exposed cable is vulnerable to being struck by objects, animals, or even vandals. This can lead to damage to the insulation, exposing live wires and creating a shock hazard. Secondly, environmental factors play a significant role. Sunlight, rain, snow, and extreme temperatures can all degrade the cable's insulation over time, making it brittle and prone to cracking. This increases the risk of electrical shorts and fires. Thirdly, accessibility is a concern. An exposed cable is easily accessible to anyone, including children who may not understand the dangers of electricity. This can lead to accidental contact with live wires, resulting in serious injury or even death. Fourthly, code compliance is essential. Electrical codes, such as the NEC, typically require that cables be protected from physical damage and environmental factors. This often means using conduit or other approved methods of protection. Fifthly, the aesthetics should not be overlooked. Exposed cables can be unsightly and detract from the appearance of a property. This is especially true in residential areas where homeowners take pride in their homes. Sixthly, maintenance is a factor. Exposed cables are more difficult to maintain and inspect than cables that are protected by conduit or buried underground. This can lead to problems going undetected for longer periods of time, increasing the risk of electrical hazards. Seventhly, long-term reliability is a consideration. Exposed cables are more likely to fail over time due to physical damage, environmental factors, and other hazards. This can result in power outages and other inconveniences. Eighthly, cost-effectiveness should be weighed. While it may seem cheaper to run exposed cable in the short term, the long-term costs of maintenance, repairs, and potential liability can be significantly higher. Ninthly, safety of workers needs to be taken into account. Working on exposed cables can be dangerous, especially if they are located in difficult-to-reach areas. This can increase the risk of accidents and injuries. Tenthly, future expansion must be considered. If you plan to add more circuits in the future, it may be difficult or impossible to do so if the existing cables are exposed. This can limit your options and potentially require you to replace the entire installation. In addition to these general considerations, there are also specific electrical codes and regulations that may apply to your situation. It is important to consult with a qualified electrician to ensure that your installation is safe and compliant with all applicable codes. Article 225 in NEC covers outside branch circuits and feeders. It provides requirements for the installation of electrical wiring for buildings and other structures. This includes requirements for the types of cables that can be used, the methods of support, and the clearances from other objects. The NEC defines a branch circuit as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. A feeder is defined as all circuit conductors between the service equipment or the source of a separately derived system and the final branch circuit overcurrent device. Article 230 covers services. It provides requirements for the installation of electrical service conductors, including the point of connection to the utility, the size of the conductors, and the methods of grounding. It's extremely important to consult with local and national electrical codes before undertaking any electrical work. Improper installation can create safety hazards and violate legal requirements. Also, consider potential interactions with other utilities, such as phone or cable lines. Maintaining proper separation and clearance is vital to avoid interference and ensure safety. Remember, electrical work can be dangerous. It's always recommended to hire a qualified electrician for any complex or potentially hazardous installations. Article 300.5 covers underground installations. This section provides requirements for the minimum burial depth of conductors and cables, as well as the type of raceway that can be used. Article 314 covers outlet, device, pole, and junction boxes, conduit bodies, fittings, and handhole enclosures. This section provides requirements for the installation of these components, including the type of box that can be used, the size of the box, and the method of supporting the box. Article 320 covers armored cable type AC. This section provides requirements for the installation of armored cable, including the type of cable that can be used, the method of supporting the cable, and the minimum bending radius of the cable. Article 330 covers metal-clad cable type NC. This section provides requirements for the installation of metal-clad cable, including the type of cable that can be used, the method of supporting the cable, and the minimum bending radius of the cable. Article 334 covers non-metallic sheet cable types NM, NMC, and NMS. This section provides requirements for the installation of non-metallic sheath cable, including the type of cable that can be used, the method of supporting the cable, and the minimum bending radius of the cable. NEC Article 390 addresses cable trays, which are often employed in industrial settings and for supporting large cable runs. Article 392 details cable bus, which is a specialized assembly of conductors in a ventilated enclosure, suitable for high current applications. It is not commonly used in residential settings. Article 396 addresses messenger-supported wiring, often seen in outdoor installations. It provides guidelines for the type of messenger wire, the attachment methods, and the cables that can be supported. In any electrical installation, it is important to ensure proper grounding to protect against electrical shock. The NEC provides detailed requirements for grounding in Article 250. Overcurrent protection is also essential to prevent damage from overloads and short circuits. Fuses and circuit breakers are commonly used for this purpose, and the NEC provides guidelines for their selection and installation in Article 240. Furthermore, it's important to be aware of the different types of wiring methods that are permitted by the NEC. Some common wiring methods include rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic conduit. The NEC specifies the conditions under which each of these wiring methods can be used. Additionally, it is essential to use the correct type of wire for the application. Wires are available in a variety of sizes and insulation types, and the NEC specifies the ampacity and voltage rating of each type of wire. It is also important to ensure that all electrical equipment is properly labeled and listed by a recognized testing laboratory. This ensures that the equipment has been tested and meets safety standards. The NEC provides requirements for labeling and listing in Article 110. Finally, it is essential to follow all applicable safety precautions when working with electricity. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and energizing circuits before working on them. The NEC provides additional safety requirements in Article 110. Remember to consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. Electrical codes are constantly evolving to address new technologies and safety concerns, so it's important to stay informed. Engaging a licensed electrician is the most assured way of knowing that you're following codes. Firstly, always ensure that all electrical work complies with local and national electrical codes. This includes obtaining necessary permits and inspections. Secondly, use appropriate wiring methods for the environment. Consider factors such as moisture, temperature, and physical protection. Thirdly, properly size conductors to prevent overheating and voltage drop. Refer to NEC tables for ampacity ratings. Fourthly, provide adequate overcurrent protection to prevent damage from short circuits and overloads. Choose the correct size fuse or circuit breaker. Fifthly, ensure proper grounding and bonding to minimize the risk of electrical shock. Follow NEC requirements for grounding electrode systems. Sixthly, protect conductors from physical damage. Use conduit, cable trays, or other approved methods. Seventhly, properly support and secure conductors. Prevent sagging or strain on connections. Eighthly, label all circuits and equipment clearly. Make it easy to identify the purpose of each circuit. Ninthly, perform regular inspections and maintenance. Identify and correct any potential problems early. Tenthly, document all electrical work. Keep records of wiring diagrams, equipment specifications, and inspection reports. NEC Section 110.3b requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. This is a fundamental requirement for safe electrical installations. Section 110.12 requires that electrical equipment be installed in a neat and workmanlike manner. This means that the installation should be clean, organized, and free from any defects that could compromise safety or performance.